Hello everyone, welcome to Homework Help. If you find the video useful, please subscribe to the channel. In this video, we'll solve an application of derivative problem. As per the problem, a right circular cone has a fixed radius r and a variable height h. The rate of change of its curved surface with respect to its height is. We are given four answer choices. We have to choose the correct answer choice. Let's start by analyzing the given information. In this problem, we have to analyze a right circular cone. I'll draw one on the board. As per the problem, this cone has a fixed radius r. We can show the radius and a variable height. That means the height of this cone can change. We can show the height of this cone. We have to find the rate of change of its curved surface with respect to its height. Let's assume the height of the cone is h when the curved surface area is a. That means we have to find dA over dH for this cone. For that, we should analyze the formula for curved surface area of a cone. The formula for curved surface area of a cone is pi r L. L is the slant height. In our diagram, this is slant height. We have to find dA over dH for this cone. So for that, we need to write this area equation in terms of variable h. As per the diagram, we can see that in the right angle triangle formed by the height and the radius of the cone, L is the length of the hypotenuse. We can use Pythagorean theorem equation to write an equation for L in terms of h. As per the Pythagorean theorem equation, L square equals r square plus h square. We can apply square root to both sides. I get L equals square root of r square plus h square. We can ignore the negative sign case when we apply the square root because the value of L cannot be negative. We can do the substitution for L in the curved surface area formula. This is the equation we can use to find dA over dH. As per the problem, the right circular cone has a fixed radius. That means for the derivative, we can assume that r is a constant. We should change the square root to rational exponent 1 over 2 because that will make it easier to find the derivative. Now we can find the derivative with respect to h. On the left side, I get dA over dH. On the right side, pi times r is a constant because for this problem, we assume that the radius is fixed. It is the coefficient of the term. So as per the constant multiple rule, it will stay the same. Next, we can find the derivative of the term r square plus h square to the power 1 over 2 with respect to h using the chain rule. As per chain rule, we start with the derivative of the outer function, the rational exponent 1 over 2. We move the exponent to the front of the term and subtract 1 from 1 over 2 in the exponent. Times the derivative of the inner function, which is r square plus h square with respect to h. Since r is a constant, the derivative of r square is equal to 0. We can find the derivative of h square with respect to h using the power rule. We move the exponent 2 to the front of the term and subtract 1 from 2 in the exponent. This is the derivative of the area equation. Now we can simplify the expression on the right side. Pi r times half is equal to pi r over 2. In the exponent, half minus 1 is equal to negative half. Next, we can multiply the terms. Pi r over 2 times 2h is equal to pi rh because the 2's will cancel each other out. So we get dA over dh equals pi rh times r square plus h square to the power negative half. As you can see in the given answer choices, square root of r square plus h square is in the denominator. So next, we can move the term r square plus h square to the denominator. That will change the exponent negative 1 over 2 to positive 1 over 2. Next, we can change the rational exponent 1 over 2 to square root. I get pi rh over square root of r square plus h square. So the answer should be option B. This should be the final answer for this problem. So these are the steps you have to keep in mind to solve this problem. I hope you'll find this video useful. Please share it, like it, and subscribe to Homework Help. Thank you very much and have a nice day. Bye.